Our next application problem to optimization is going to involve a coordinate geometry example, and we're going to be looking at a parabola and putting a rectangle inside of that so that we can maximize the area of our rectangle. In this problem, we want to find the maximum area of a rectangle whose base is the x-axis and it is inscribed under the parabola 4 minus x squared. So let's plot our points. We know we have an upside down parabola with the vertex at 0, 4. We have a point at 1, 3, at 2, 0, at negative 2, 0, at negative 1, 3. And I can go ahead and kind of connect those dots into an upside down parabola. And what I'm going to do is I'm going to inscribe a rectangle in that. And I want to find the rectangle that would have a maximum area. So keep in mind that what's happening here is that your rectangle is going to touch your parabola over here at some point xy. So if I look at this to find the area of this rectangle, I'm going to need to multiply the length times the width. Well, if that point is xy, then that means that the distance from the origin out to the edge of my rectangle is x, and then from the point there to up on the parabola would have a distance of y. So my equation for the area of my rectangle would be 2x times y. And we're going to use that when we finish solving this problem algebraically. We know that our equation for the area that we were just looking at was given as area equals 2 times xy. And we also know that y is 4 minus x squared. So substituting in, we get this. Now I'm going to go ahead and distribute and get 8x minus 2x cubed. And then I'm going to take my derivative and get 8 minus 6x squared and set that equal to 0 so I can find my critical points. So if I solve, I'm going to get that x is positive or negative square root of 4/3. And if you think about your picture, it makes sense that you get both of those because the way the rectangle is going to fall inscribed in your parabola, if this side is at the square root of 4/3 and then whatever the y value for that would be, this point's going to be negative that same value and then up y. So we just need to consider one of those. Let's double check a double prime to make sure that this is going to give me a maximum. Well, if I take my second derivative, I get negative 12x. And if I let x be a positive number, we're going to use the positive square root of 4/3. Then I get a double prime of the square root of 4/3 is going to be a negative value, which tells me that I have my maximum area, which was what I was looking for. Now, I haven't answered the question. I've just found what I need x to be. And again, if we will go back to right before our derivative, you have your area equation in terms of x. So we just now need to substitute in the square root of 4/3 for all of the x's. And solve that. And if you do, you're going to get 6.158. And I do recommend that you take the time to go back with your calculator, put in the square root of 4/3 for your area equation, and make sure that you do get 6.158. And then since I don't have units on this, all I know is that my area would be units squared. And that should be the maximum area that I can have if I inscribe a rectangle underneath the parabola 4 minus x squared.